Hi, so today what we're going to do is we're going to take a look at one of these Arduino compatible boards, in this case the Grove Beginner Kit from Seed Studio, and we're going to send signals over the USB to our PC or Mac OS, Windows 10, etc. When we press the button right here. So we're going to figure out how to send information from this board, and we're going to figure out how to receive it on the computer. Okay, so the very first thing that we're going to do is we are going to write the Arduino code right here. So I've got a almost blank template. So we're going to start like this, and we're going to configure one of the inputs, the digital inputs, in this case D6, to be an input, and this is where the button is. Okay, and we're also going to enable serial communication at 9600 baud. Okay, which is the speed of like a fax machine sort of thing. So this is to enable serial. All right, so that's in the setup. And then over here, what we're going to do is we're going to set up a loop. And in this loop, we're going to have an if statement. And that if statement is going to look for the button. So we're going to say if digital read DD6, so it's on D6, like that, is equal to high. And depending on your own button, it might be high or low. It depends. In this case, we're looking for high. Then we're going to say, let me see, we're going to say serial write button, like that. Okay, with an n/n at the end for new line, like that. Okay, and this means that the button was pressed. Now, what we're also going to do is we're going to put a little delay in here. Okay, so the delay of 400 milliseconds. And the reason is this is for debouncing and to not have repetitions for long presses. So buttons can vibrate when you press them. They're minute little things, and they can sort of trigger multiple signals. You can also have long presses on there, and we only want to send the button exclamation mark signal once. So as long as somebody's sort of pressing reasonably, it will only be sent once if you've got serial write and then a delay of 400 milliseconds, give or take a little bit. All right, then after that, we're going to say else, and nothing in that else branch. And that's it. But we can also say, we can do something like this, serial.available. If it turns out that the serial port is blocked, we want to block that. We want to stop the program. Okay, and that blocking can happen for a number of different reasons. Generally because you've got two programs trying to access the serial port over USB at the same time. Okay, so we've now got that. I'm just going to compile it and make sure it works. And as you can see right here, my board. Hold on. Oh, I think I missed an include. Hold on a sec. So I need to include Arduino.h. I think that's what caused that problem right there. Nope. Oh, that. There. Okay. Serial.available. I had to spell that right. Okay, so we're compiling that. Bingo. All right, so now we're going to send it into the board. I'm going to send that into the board right there. All right, and then, well, nothing happens. So what we need to do next is we have to open up a program called a terminal program. And this can be, CoolTerm is really good on the Mac, RealTerm, which is an alternative that works on Windows as well. And there are alternatives as well in Linux. So in this case, what we have to do is we have to set up our options, and we have to say that our port is this one, the same one that we're using on the Arduino over there. We want our baud rate to be 9600, and then the data bits are 8, parity none, stop bits are 1. Those are really the default for most of the serial examples that we're going to have out there. Everything else you don't have to worry about. So then we go OK, and then what we do is we say connect. Now, I'm now going to disconnect. Okay, and let's try that again. I'm going to go and connect. And there's actually, disconnect. We can see that. Little lights that flash. It's in the process of just sort of making sure that something's there. So that's now connected. And if I were to say, try now to download code from the Arduino program in, it'll be blocked. It has problems uploading to the board because the CoolTerm is currently connected to the board. The Arduino IDE can't get connection. You have to disconnect on this side, hitting the disconnect button right here. If I do that and try to re-download, you'll see that it works. And so this is important to point out because we'll have the same issue when we write our own Java program afterwards, okay? So we've got this going right here. It's now downloaded. And so what we're going to do now, so once it's programmed on the Arduino IDE, the port is released. And so we should be able to connect at this end. We are connected. And now if I press the button, you can see on the terminal program that it says button because that's what we programmed in right there to be sent over the USB cable. Okay, so that works. That's a really good way to verify that things are working properly. Now, if you have the baud rate set wrong, so I'm going to disconnect and I set it to some faster rate or something. Okay, I go like this. Okay, I connect. It'll still connect, but if I hit the button, you get garbage out. Okay, or you get garbage into the terminal program. So you got to watch for that. You got to make sure your baud rate, etc., is correct. So if I go to 9600, say OK, I'm still connected. There we go. We're good. Okay, so baud rate's important. Now let's go over to write the Java program. So I'm going to, oops, before I do that though, I'm going to disconnect from our terminal program. All right. So we're now over in IntelliJ, and in IntelliJ, I'm going to start 2 new classes. So I'm going to start with main. So I'm going to have main, and then after that, I'm going to start another one Java class. I'm going to call this one. Let me see. I'm going to call it timer schedule. You know what? Let's see if we can get it automatically set up. All right, so I got my public main right here. All right, and in public main, I need to import com.phasecast.jserialcom like that, and serial port. All right, and then I'm going to import java.util.timer as well. Now, phasecast jserialcom isn't recognized, so I go into File, I go into Project Structure, and I'm going to use Maven to go and download that library. Libraries, add, Maven. And then, let's see, it's com.phasecast, like that, colon, jserialcom, like that, Shift Enter or Shift Return, or hit that magnifying glass right there. It'll do a search on Maven, looking through the Maven repository, and I can find jserialcom 2.6.2 right there. Add it as a module. Click, 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 and it should recognize it. It's done. Good. We're good. So now inside of my main class, I need a main method, a main function. And so that's all set up properly. Now I'm going to start by, inside this method, I want to record what time things start at. So system.current time millis, so milliseconds. So this is going to be an integer, and this integer is going to record the value of time at the very beginning. Okay. Next, I'm going to guess at a type here, but I'm going to have a serial port SP object that is created from serial port get com port, and I need a string that will describe what the port value is, and this is different on different machines. Now in my case, I saw it in the Arduino IDE. Whoops. There. All right, so this right here, it's dev cu slab USB to UART, right down at the bottom of the Arduino screen. So I go like this, I go slash dev cu dot slab USB to UART, like that. All right, next up. And that'll be different on everybody's machine. You have to configure it for your own setup. Okay, so then now we need to set up the COM parameters just like you saw on CoolTerm or RealTerm. So COM port parameters, I want to have a baud rate of 9600. Yeah. I'm going to be sending in information over, or if I was going to be sending data, it'd be over bytes. Serial, let's see, serial port, one stop bit there. Yep. And then we want no parity. Serial port dot no parity. Parity is basically error checking, and the default for most of these systems is no parity, no error checking. All right, then we do, let's see, we do figure out about timeouts. Set com port timeouts. Not a big deal, but we might as well. We're going to do right blocking like that. We're going to do 0 and 0 like that. All right. Then we're just going to make sure that things have opened. All right. So is equal to sp.open port. You saw that it can actually be really problematic if we're blocked, right? So we just want to make sure that this is, and so it's a relatively common occurrence. So we want to deal with it. Has opened like that. And we want to throw an error or an exception, legal state exception, and we want to say failed to open serial port like that. Okay, just in case something couldn't be opened. Next, we're going to make sure that as things close down, as our program closes down, we also make sure to shut down the port, because we want to, just like CoolTerm did, it released the port when we wanted it to. We need to make sure that when we exit, we do the same thing. Okay, we cleanly give up the resource so that other programs can use it. Okay, and by the resource, I mean the USB line. Shut down hook. Yep. And here we're going to use a lambda. Like that. And we're going to add this sp.close port to, it's going to make sure I got all the parentheses in that right, like that. We're adding a close port command when things shut down, and we're using a lambda. You can tell it's a lambda by this right here. And a lambda basically is an inline function. It's basically a shorthand way of, or a short way of writing in a function in line with what you're doing. Okay. Next, we go for timer is equal. We're going to set up a new timer because we want to have scheduled. We want to be able to check things on a regular basis. Okay. This will also help when we want to send stuff to the Arduino later. So we have a timer, timed schedule like that is equal to new, and we're going to create a new class called timer schedule handler, and we're going to send it the time start value. So we're going to tell it what's going on. Okay, like that. And then we're going to add a data listener, like that. And we're going to send it timed schedule like that. Then we're going to go syst s out. And we're going to say, just going to listen like that. Timed schedule dot get listening events, just to see what's being sent around. Okay, we're going to put that in there, and then we're going to go and timer dot schedule timed schedule with 0 delay, and we're going to schedule the task to run basically once every second, like so. All right, and this will allow us to build up a program that not only listens but also sends data on a regular basis. So that is more or less where we want to be. We now need to create this this class. Okay, so we're going to create the class. I should do it like this. URQ like that. Like that. Okay. Yeah, that's going to be long, like so. So this is my new class, and this class will take care of a lot of the serial sort of business that we need to do. All right, so we are going to import in a couple of things like this. So we're going to have a timer task, then we're going to have a couple of things related to serial ports. We're going to have the general serial port, then we've got serial port data listener and serial port event, because when we receive information, that's an event that we need to take care of. All right, so then in here we have a timer schedule handler, and whoops, I need something right here. I need a private variable, private final long time start, because we're going to be passing this in, and we want a sort of a local copy inside of the work that we're doing in this particular class. All right, so now we have a constructor. So this is the constructor right here. And what this does is it initializes things the first time the class becomes an object, and that object is run. Okay, so here we're going to say this, so we're referring to this class, eventually this object. Okay, so this, and we're going to say time, whoops, so the time start that's inside of this class is going to be equal to the time start value that is passed in as a parameter from main. We did it over here. Okay, so we're going to be passing that in, but we're going to copy it over and assign it to the private variable called this.timestart. Okay, and that's it for the constructor. Next, we want to override the run method in timer task. Okay, so timer task allows us to have a repeating sort of method that runs over and over and over again at predicted or predictable times. And in this case, the method is called run. So we call it we want to at override. Okay, so we have to override the existing from the timer task class that we're importing. We need to have we have to have run. So we're going to go public void run like that. And then inside, all we're going to do once every second is we're going to print something out. So we're going to go s out like that. And we're going to say time elapsed. So we know that something's going on. Okay. And we're going to make this system.current time millis. So we're going to ask for the current time value, and we're going to subtract time start from that. And then we're going to concat, this.time start. Oops. Yeah. And then we're going to concatenate milliseconds like that. That should be good. And that'll happen once every second, basically, based on what we call in the main method. Now, I did forget something here. So in class timer scheduler, we have to extend, forgot to do that, timer task. All right. And we also have to implement, okay, so we have to implement serial port data listener from Phasecast. All right. So those two things have to, and so these will be used inside of the class timer schedule handler. All right. There we go. So that override's done. Next, we have to do, we have to take a look at the get listening events that comes from Phasecast, and we're going to do an override on it too. So override. So we're saying that we're basically modifying it, or making our own version of it here. So this is going to be public int get listening events like that. Okay, and then here we're going to simply return serial port dot listening event data received. Okay, so in the event that something has been received, we want to be able to flag it. Okay, so we've got that right there. Next, what happens? So we have to flag it, but then we have to do some action based on that. So if something's been received, we want to log that as an event. Okay, override like that. Yep. Right, and now it's going to be public void serial event. Okay, because these are events. Serial port event. Okay, we're going to pass this as a parameter into this method right here, serial port event, like that. And if you're curious about some of the details here, you can go into the JSerialCom documentation to read up a little bit about it. And we'll talk about it more as the semester goes along, because I know that this is a lot to take in all at once. But we want to do something useful, so we have to cover a lot of this all in one shot. But we'll go into detail about it later. So get event type, event, yeah, like that. And we're going to ask if this is a serial port dot listening data received. Okay, so was data received. We don't know what data it is. We just want to know that something was received. So it doesn't really matter what was sent. Then we go system, at least in this particular example. Okay, system.out.print line like that. And we're going to say, yes, the Arduino is alive. Okay, button pushed. Like that. And we go semicolon like that. And that, I believe, is that. I think that we've got it all. So I'm going to go back into main like this. Not seeing any red. Let's go and compile it. While that's compiling, I'm just going to make sure that CoolTerm is disconnected. That's good. So we're not going to use it. All right, so we don't have any errors in compiling. Good. So now we're going to run this. Okay. All right, here we go. So it's showing elapsed time. So it looks like more or less we're going in sort of 1 second increments. So 74.21 milliseconds, then 84.24 milliseconds. So it looks like we're jumping in 1,000 millisecond increments. All right. So now I still have this connected. So now I'm going to press the button. Now, nothing will happen on the board right here, but what we should see is something occurring on the console in IntelliJ. There we go. Look at that. It's always nice to see something actually working. So there we go. So it is receiving every time I push. It is registering it and printing to the console. Things are working. Now, this is going on. Let's see if we can actually connect using this right here. So we're going to try and connect. Oh, we're actually we're getting a little bit of crosstalk here between the two applications. So it's kind of working, kind of not. So we're just going to make sure we disconnect from CoolTerm. Okay. All right. Well, there you go. We have a working program. Good luck, everyone.